Right, so here we're tackling some rational functions. So here's an example of a rational function. We studied these in pre-calculus, right? Let's call this f of x. And let's say we want to start the limit. Actually, let's not even worry about that yet. Let's take a look at the graph of f of x to start. Let's remind ourselves what this looks like. So here's my graph of f of x on Desmos. So notice we are already just kind of naturally get these two separate pieces, right? So we have what's called a vertical asymptote at x equals -6. And that's because, and you can check this if you want, if I plug in -6 into my denominator, well, I get 36 minus 36, right? Which is just 0. So x cannot be equal to 0 because the dividing by 0 is not defined, right? This graph also has a hole, which does not show up at Desmos. So let's remind ourselves first, before we start thinking about the limits, how to find this vertical asymptote and how to find this hole algebraically. So this is a little bit of review. So what we will do here, right, is factor the top and bottom. So I can pull just an x out of the top, right, because if I distribute that x, I will get what I started with. And on the bottom, same thing, I can pull an x out. It's plus 6. Okay. Notice now that we can cancel the top and bottom, right? So the x over x is just 1. When those cancel out, f of x can be simplified, right? So let's keep this in mind, and let's consider two limits here. So the limit as x approaches 0 of f of x, and the limit as x approaches -6 of f of x. So maybe you see where I'm going with this already. Okay? So notice if I try to plug in my 0 directly, that's not going to work. That's going to get me a 0 in the denominator. But what I can do is use my simplified version. So I can say that this is equal to the limit as x approaches 0 of x minus 3. And that solves that problem for me, right? So I can plug in 0 on the top, 0 on the bottom. 0 minus 3, -3, 0 plus 6 is 6. So that simplifies to -1/2. Okay? So this limit exists because that 0 canceled out, right? From our work in pre-calc, what this would mean is there's a hole in this graph at 0, -1/2. So that was that hole that didn't show up on my graph on Desmos. So the way we approach that in calculus, or a way we can describe that now in calculus, is that the limit as x approaches 0 is -1/2. And that would correspond with the hole in the graph. Now notice -6 did not cancel here, or rather x plus 6 did not cancel here. So this is still equal to the limit of f of x as x approaches -6, or x minus 3 over x plus 6 as x approaches -6. That didn't really get us anywhere, right? Let's remind ourselves what the graph looked like. So here's that -6. Clearly, the function approaches two different values on either side of -6, right? So on the left, my function is going up forever, approaching infinity. On the right, my function is going down forever, approaching -infinity. Okay? So this was a limit that does not exist, because the left and the right limits are not equal to each other. So we'd say that limit does not exist. And then this corresponds, right, from our work in pre-calc, to a vertical asymptote at x equals negative. Okay? So for the purposes of this lesson, we're going to complicate this a little bit in the future. When you run into these vertical asymptotes, those limits do not exist. So we're really focused on this idea of a hole in the rational function at -1/2. The last thing you may run into, I'm going to do a third limit. So the limit, and I'm just picking a random number here, as x approaches, let's say 1 to make it easy. Limit as x approaches 1 of f of x. So the last limit is neither of those, right? So that's going to be just equal to, you can use either your original function or the simplified function. It doesn't matter because they're equivalent outside of the whole. The limit as x approaches 1 of x squared minus 3x. And then x squared plus 6x. Well, in this case, we can just plug it in, right? So we'll get 1 squared minus 3 times 1 over 1 squared plus 6 times 1. And then what do we get here? 1 minus 3 is negative 2. Oops. Over 1 plus 6 is 7, so negative 2 sevenths. Okay, so when in doubt, plug it in, right? In these cases, if you plug it in and f spits out a number, that's the limit. Okay. If f does not spit out a number, then try to simplify we did here, and you will may or may not be able to find the limit here. So just keep in mind that this does not exist is an option for these.